Okay, let's see if we can finish the explanation of the function. So the last time we had the two error checks, one to make sure that the string is long enough, and the second one to make sure that the string ends with little x or big X, and now we start the actual calculations. So what did I do? I defined a string, and the string is called possible, and it's the length of 22, and you will see the usage of that string. That string has all the legal characters that should be in the input, and the legal characters are 0 through 9, all the digits, and then all the letters A through F, the lowercase, and A through F, the uppercase. So those are all the allowable characters in the string that the user enters. Now here I define something that you're not familiar with, but anyway, we'll just explain it later, but this is called a pointer to a character. So it's not important right now to know what it is. But anyway, we'll go over this thing in another time. And here I define double sum, and I put 0 into the variable sum, and the sum will accumulate the number in decimal. When we start converting from hex to decimal, sum will accumulate the number. And then I define integer, real digit, and character dig. You will see the use of those definitions in a short moment. And now I start a loop, a for loop, and the for loop will go over all the characters of the string of the input, the hexadecimal string. So I have a variable I equals to 0 as long as I is less than len minus 1, and if you remember, len was the length of the string minus 1 because the last one is the x. We don't have to convert the x. And then plus plus I, the standard for loop, and we start. So the first thing I do is I put into dig, which is a one character, I put the current character that I'm taking from the string. So the string was hex, and I use the index len minus I minus 2. First time the I will be 0, so it will be len minus 2, and len minus 2 will give us the index of the character. For example, if the number was AFX, len will be 1, 2, 3, len minus 1 will be 2. So if I use the index len, which is 3 minus 0 minus 2, 3 minus 2 is 1, and this will give me, this is index 0, index 1. So it will give me the first one on the left of the x. So I want to start from here and go to the left, right? So the first one goes into dig, the first character, and then I use a function that's called strcar. Strcar is a function that checks if a character, which is the second parameter, is inside the string. If this character is inside this string, it will return the location in P. If it's not, it will return something that's called null. So I'm checking if the digit, the character that I put into dig, is one of the possible characters. And the possible characters, if you remember, were here. All the digits 0 through 9 and the letters A through F, both lower and uppercase. So if the digit was one of those possible, then P will be good location. If not, P will be null. And I'm asking if p is equal to null, that means that one character was not legal, not possible, and I'm giving a message. Hex string has a character that's not a digit. And I even print that character that's not a digit because it's inside dig. And then I return from the function with -1, and the function ends here. So it doesn't matter that if we are inside the loop, if we say return, the function ends immediately. Now, if p was not null, that means p was a relocation, that means the dig was found in the string possible, and then we continue our function. So we go to the else, and here we process the digit. What do? We ask. Now we use another function. The function is called isDigit. Those are functions of C. The C library has all those functions. isDigit returns true if the character we're using it on, the parameter, is a digit, and false if the parameter is not a digit. So now we're asking if dig is actual digit, if it's 0 through 9. If it's actual digit, then we put dig into the variable real digit. Okay, so real digit could be 0, 1, 2, 3, up to 9, because isDigit told us that it's actual digit. If the answer was no, we go to the else. That means isDigit told us that dig is not a real digit. So our conclusion is dig must be one of A through F, either lowercase or uppercase, because we already checked that dig was a possible character, so it must be either a digit from 0 through 9 or a character from A to F, either lowercase or uppercase. So when we're here, we already know that dig is good, and if it's not a digit, then it must be A through F. And now I check with another function that's called isUpper. isUpper checks if a character is an uppercase. If it's an uppercase, isUpper will give me true. If it's not upper, if it's lowercase, isUpper will give me false. So here, if it's true, I'm going here, and the way I calculate real digit, and this is a tricky calculation which I will explain after this session, but let me just say that if I do real digit equals 10 plus the digit minus a, large A, in quotes, it will give me the value of that digit, which was either A, B, C, D, E, or F, uppercase. So if the digit, for example, was F, it will be 10 plus F minus A, and it will give me the value 15. So we'll go over this calculation later, and we'll talk about ASCII code and how the letters are being interpreted into numbers. But just take my word for it right now that real digit will get the value of the real value of the character in hexadecimal. Real digit will get it in decimal. And else means that it wasn't uppercase. We'll do the same thing with 10 plus dig minus little a here, and this will give me the value of that hexadecimal character in decimal. So after we finish that, all we have to do is sum plus equals, means sum equals to sum plus the real digit that we found times power of 16 comma I. And power, we already know this function. It takes this number and it raises it to the power of this, and this is what we do when we calculate hexadecimal converted into decimal. And at the end we'll do return sum. I will have to repeat more stuff, but for now it's enough.